Hey guys, welcome back. In this video, we are going to derive the proof for the quotient rule of differentiation. If we have the function which can be written as the quotient of the two functions, okay? Example here, if we have y equals to f of x upon g of x, okay? This y is the function of x, but it can be written in the quotient of the function. Okay, we have the rule of differentiation where we can evaluate this directly. For this, the direct way to do is differentiation of f of x upon g of x with respect to the change in x is just whole expression divided by the square of the second function. On the numerator, we have the function at the denominator times the derivative of the function of the numerator, this numerator, minus the function at the numerator times the derivative of the function at the denominator. And this is the quotient rule of differentiation. If u is equal to f of x and v equal to g of x, then in short we can say that differentiation of u upon v with respect to x is v squared, v times differentiation of u with respect to x minus u times differentiation of v respect to x. So this is the product rule of differentiation. Now let us prove why this one is equal to this expression by using the first principle or the limit definition of the derivative. For this, we have that if y is the function of x, then y prime is the derivative of the function of x. So that dy upon dx or f prime of x in the limit definition is limit h approaches to 0 f x plus h minus f of x upon h, where this h is the step. Okay, so we should keep this in mind, because upon modifying this equation we have to reduce to this form to apply the limit. Now we can express this in the limit definition as d upon f of x divided by g of x with respect to x can be written in the limit definition as limit h approaches to 0 f of x plus h minus f of x divided by gx plus h minus g of x all divided by h. Now we can modify this function by finding the common denominator. For this, the common denominator will be gx plus h times gx. So we can modify this expression as g of x times f of x plus h, right, minus g of x plus h times f of x all divided by h gx plus h times g of x, right? We have just found the common denominator. Okay, now what we can do is we can modify this term by adding the extra term to reduce to this form to apply the limit. So for this, in this expression, if we add and subtract f of x, g of x plus f of x plus g of x, then the whole sum is 0. So if we add 0 also, the whole meaning of the equation will not change. But upon adding this, we can modify this in order to change it to this form. So by incorporating this modification now, this can be written as limit h tends to 0. Let's bring this here. 1 over gx plus h, right? This, okay, times 1 over h. Now we can write this here again, g of x f of x plus h minus f of x g of x plus f of x g of x minus gx plus h f of x. Okay. Now what we will do is, as we know that the limit of the product is the product of the limit, yes or no? As we know that the limit of the product, whole product, is the product of the limit, which means this limit should be distributed to this as well as this and all of this term, right? Before doing this, let's collect the like terms here. So we can write limit h approaches to 0, 1 over g of x plus h g of x times 1 over h times, see here in this expression, this g of x and g of x is common, so we can take g of x and f h plus x minus f of x, okay, plus here we can take f of x as common. We have now g of x minus g of x plus h, right? Okay, all right. Now let us distribute this h here and apply the limit. Now see here, limit of this 1 over g of x plus h and g of x, right? Times h approaches to 0 times limit of h approaches to 0 g of x f of x plus h minus f of x divided by h plus, see here we can modify this by taking the minus sign to become f of x, right, gx plus h minus g of x divided by h, right? And this whole limit will apply to both of the function. Now we have to distribute here as well as we have to distribute here, because the limit of the product is the product of the limit, yes or no? This is according to the limit rule. Now applying this, we see here that when h approaches to 0, what happens? Gx plus h will approach to g of x, right? And this g of x is independent of the h. Now with this we will have, this will reduce to g of x and we have here g of x. Thus it will reduce to 1 upon g of x the whole squared, right? Times, see here, by applying this limit here as well as here, what we will get now? We will get g of x limit h approaches to 0 f of x plus h minus f of x whole h minus f of x limit h approaches to 0 g of x plus h minus g of x upon h, right? Now with this we know that from the limit definition that this expression and this expression is just the f prime of x and g prime of x, and here this f of x and g of x is independent of the limit. Even if you distribute this limit here, it will remain as g of x only. Thus we now got the final expression of the quotient rule, which is 1 over g of x whole squared, right, times g of x times, what is this, f prime of x minus f of x times g prime of x, which can be also written as g of x times f prime of x minus fx times g prime of x upon gx the whole squared, which is exactly this form, right? Therefore it is d of f of x upon dx of g of x. So this is the quotient rule. This is very powerful result because we use almost all the time. I hope you all have enjoyed this proof and understood the proof and also begin appreciating the beauty of the math. Thank you, and I'll see you in next video.